Okay, let's dive into how to build step functions from AWS using Rust. Step functions are really powerful in terms of serverless workflows because you can chain together multiple operations and take the input of one Lambda function, process it, and then put the output into another Lambda function. And what's really fun about it is you can drag and drop and create your own workflows, almost like working with Legos. And you can see here, this is a diagram of the workflow. And then when it runs, you can actually introspect and go right into the details of what one function is delivering and what the other one is receiving. And this is incredible in terms of debugging. So can you do this in Rust? Yes, you can. All right, let's go ahead and take a look at how you would do this in Rust. First up, I have a step functions directory right here. And inside I have a Rust Marco, which will be the first step function. And then I have a Rust Polo. All I needed to do in order to create this was use the excellent Cargo Lambda library, which you can see here. I just said Cargo Lambda new Rust Marco. And if we go into the source code right here and we take a look at it, I have an input here, which is the struct. And this is the, actually, let's go to this one right here, which is the name. And this would be the input to the function. In terms of the output, we would have the payload that's being sent. The handler is where all the work is done. I have an async handler right here, and we say let name event.payload name. So I take the name value from the JSON payload, and I say, listen, if the name is Marco, then I would actually like to make the payload body Polo. Otherwise, let's make it nobody. And I also add some tracing here so that I can have some debugging inside of my Lambda console. Now next, all I have to do is prepare the response, right? And so this will be the return payload. It's automatically serialized for us when we send the OK. And the payload body right here is, again, just what's inside of here. Now to deploy this or run it or whatever, I like to use makefiles. And so what I do here is I say make release, and all it does is run Cargo Lambda build release. We can actually go into this directory real quick and take a look at it. And let's go to step functions, Marco, Rust Marco here. And we can say make release, and we can see what it does. Right, there we go. Right, it's already been released, so we don't have to do anything. And then if I say make deploy, it would then go ahead and redeploy the function. You can see again, since it didn't have to do anything, it was very fast. Now, if I want to invoke it and see what the payload will actually be, I would have to say Cargo Lambda invoke remote, put the name of the AWS Lambda function here, and then send in the payload. In this case, again, the makefile makes it easy. I just go ahead and say make invoke. Now, what's great about this is then I can do the same thing for the second one. So let's go over to Rust Polo here. Let's look at this one. So I know that I'm going to have to accept a payload. That's the body of the other Lambda. And then I'm going to return a payload as well. So at first I say let the name is equal to payload. And then if I look for the word Polo, right, that was the successful response from Marco. I say you win. Otherwise, I say you lose. And again, I add some tracing here. Very simple. Yet again, I just add a response right here, which gets serialized and sent back to the user. Yet again, if I just go ahead and I CD up here and we go into the Rust Polo, right, we can say make invoke. And this will be a little bit different, but not much, which is that I'm going to send in the payload Polo, right? And this would say you win. Now, if I want to change it, for example, and I say, no, for example, and we change that, it's going to say you lose, right? So a very, very easy and convenient way to build Lambda functions. And you can see it's very straightforward. So now to use them, what do we do? So we can go over to the step functions right here, and let's actually just make a new one. So I'm going to go ahead and say create new state machine, go next, and it's just like Legos. I just drag one, and we can call this one, Rust Marco, and then we could build another one after this one. But first, let's give it the Rust Marco here, which is this one, and then we drag a second one, and we say Rust Polo. And this would be, instead of Lambda invoke, we'll call it Rust Polo. Rust Polo. There we go. And then again, we just go ahead and choose this and we say Rust Polo. Now what's beautiful about this is that we're done, and it gives me the JSON output if I want to copy this and store it somewhere. But you can see here, here's how it works. Once I've verified that that's what I want, then I can name it a step function. We'll call this Rust Marco Polo chain. And we can go ahead and say create state machine. Now, in order to execute it, I could call it from the command line, which is actually a nice way to do it. Or I just say start. It gives it a optional globally unique ID. And then here's where we have to chain things together. I would just say name here, and we would say Marco. And this will start the chain. We go over, we can watch it actually being executed. And we can say the first input right here, which you can see that the payload that was returned was Polo. And then we can see this one is UN. So really straightforward actually to run this. Now, if we want to do a failed execution, let's go ahead and do another one. So let's go back to this, and we'll do another, and let's just leave this default here, and you can see it'll actually blow up. It won't work. So, there's a problem, error message, right? And we can see that it failed. So it's very good debugging as well. And this is a great way to build reproducible services with Rust and AWS. And hopefully you give this a try.